CSC Grade 7 Mathematics session. Last time we had to cut short because I was not feeling well, but today we are going to continue. From today onwards, the sessions will be only half an hour long because the 1 hour sessions are creating a very long session that kind of me feel a bit uncomfortable. So we will experiment with this half-hour sessions for a few days and see what happens. Okay. So today we are going to do angles, lines, and parallelism. Okay. So it sounds like angles, lines, and okay, sorry. So basically what happens is we will start with angles first. Okay. Angles are made up of two rays coming out from a single point in two different directions. Let's see my cursor. So this is an angle. So here um, we are going to try different type of angles. So let's start with the type of angles that we are going to do. Okay. So let's start with types of angles. So first angle that we are going to do is zero angle. As the name suggests, the zero angle has a measure of 0. So let's say this is your O, this is your A, and then again we have another one here, it is B. So angle AOB is equal to 0 degrees. Now whenever we are talking about an angle, we generally talk about all the three letters, and this middle letter is the letter or the vertex. So the angle is O. But whenever we are just saying angle name, it is preferable to say it in three alphabets or a small alphabet that can be written like A or small b. But never just say angle O or angle B, because there may be multiple angles at the same point of vertex. Okay, so zero angle has measure of 0 degrees Celsius, 0 degrees, not Celsius, sorry, 0 degrees. Now second angle is an acute angle. Most of us know this angle. The measurement of this angle is between so anything between 0 to 90 is an acute angle. So it can be may look like this. So this is A, this is O, and this is B. Since O is at the center, I'm going to write it at the vertex. So angle AOB has to be between 0 and 90. So it can be 0.00001 degrees to 89.999999999 degrees, theoretically. Next one is a right angle. Okay. Now, in this case, your angle AOB is exactly 90 degrees. So it's something like this. It's so difficult to draw a straight line on this. Okay. So a right angle is always represented by a small square at the vertex. So AOB is a right angle. So whenever you see this sign here, it indicates a right angle. So anywhere in your problems, whenever you see this sign, you can directly consider it to be 90 degrees. You don't even have to think about it. It's like the sign signifies that the angle measurement is 90 degrees. Oh. Next one is this was the third type, right? Sorry. Now the fourth type is obtuse angle. Now obtuse angle is 90 degrees is less than angle AOB is less than 180 degrees. So angle measures between 90 degrees and 180 degrees are called obtuse angles. So something like this. They visually look bigger. See this side. So now next one is a straight angle. So your angle AOB is exactly 180 degrees or a straight line. That's why it is called a straight angle. This is O, this is A, this is B, and this, my dears, is 180 degrees. So this is a straight angle. Then we have something called as reflex angle. Now reflex angle is from 180 degrees to 360 degrees. So it is between 180. So it is greater than 180, but it is smaller than 360 degrees. So it will look something like this. Okay, and we are looking at this side of the angle. So a reflex angle can be calculated by calculating this side of the angle, the yellow side, and subtracting it from 360 degrees. Now when we come to measurements of angles, we use a protractor. A protractor is an instrument in your compass box which looks like a D. Okay, and it has markings from 0 to 180 and 0 to 180 like this, and there is a straight line at the center, a circle over here, there is a center marked over here, and this is 90 degrees, and there are a lot of angle measurements over here. I'm going to show you this and how to use this to measure your angle, but this is in general, it is called a protractor. Now nowadays in market you get a 360-degree protractor. So if you have it, it's good. If you don't have it, the 180-degree protractor will also do the same job. Okay, so I'm going to share the another site on which we are going to use learn how to use a protractor. So give me a moment. I will help you with that. So as you can see, we have this construction tool website. You can use it if you want to use an online version. It's mathspad.co.uk. Uh, and it comes very handy when I have to teach online or when I have to show you guys how to use something. So let's draw a line first. So this is my line. Okay. Now this is my arrow. So that means my vertex is going to be here. So I'm going to write O over here and A over here. Now I'm going to take another line. Let's see, line B. Okay, like this. I'm going to draw the arrows here like this and B. Now I have to measure what is the measurement of this angle. So I'm going to take my protractor. Now here I don't have a 360-degree protractor, so I'm going to use a 180-degree protractor. Now I'm going to place this center, this here, on my vertex. Okay, on my vertex. And I'm going to look at in which direction my arrow is going. Okay. If you see, and I will match the 0 on the arrow line. So my arrow is going in this direction. So I'm going to use this 0 here. Okay, and I'm going to go 0, 10, 20, 30, 40, 50. So my angle AOB is 50 degrees. Now, if you see, I can measure up to 180 degrees over here. So I'm going to show you how to measure an obtuse angle also. So let's erase all this, okay, and keep our protractor away for some time. Now I'm going to draw another angle. So now these arrows are very important because they tell us where our vertex is and which side of the protractor we are supposed to use. Since we use the other one side of the protractor, let's use this side of the protractor. Okay, so I will draw a line slightly this side, and now my arrow is here, A and O. Now I'm taking another line and I'm drawing in this direction. Okay, and this is my B. Now the angle that I'm going to measure is this part of the angle. So again the same thing, place your point at the vertex, match your zero line with the arm that is downwards, and then start counting. Now my zero, my and the arrow is pointing towards this side, so I'm going to use this zero. So it's 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, and 143. Okay, so my angle is 143 degrees. Okay. So this is how I measure an obtuse angle. Now the last one is a reflex angle. Now let's say my A again pointing towards this side. Okay, this is my O, this is my A, and my B is here somewhere. Here. Okay, this is my B. And now I have to measure this side of the angle. Now it's easier to measure this side and then subtract it from 360 because the entire this side plus this side, they together make 360 degrees. So we are going to measure the blue side of the angle and then subtract it from the 360 degrees. So first of all, we are going to turn this upside down. Okay, again same thing, we are going to put the vertex at 0, at O, and we are going to match our OA line with this bottom line, and we are going to start with this 0 here because our arrow is pointing at this side. So it's 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 124. So the blue angle is 124, okay, degrees. So our black angle or the reflex angle that we need is 360 minus 124 is equal to 236. So 236. Whenever someone needs a reflex angle in somewhere, they will be specifically mentioning that you need to find the reflex angle AOB. If that is not mentioned, you can always find the obtuse side of the angle and leave it at there. Okay, so this is how you use a protractor. If you have a 360-degree, this job is much easier. You don't have to do all the subtraction because it will directly give you the 236 mark. But those normal compass set or normal geometry set will always contain a half D. This is called a half protractor or a D. So you have to learn how to use it in order to find a reflex angle. Now let's go back to our board. Okay, because we are going to learn something called as complementary angles, supplementary angles. These are very important before we start lines. Okay, so understanding angles is important because once you understand the angles, then only you can understand lines. So for understanding lines and parallel lines, you have to first understand the angles. So now we have our complementary angle. Okay, so first type of angle is complementary angle. Complementary angles mean that a group of angles which add up to 90 degrees. Their measures will add up to 90 degrees. So obviously, all the angles that are getting added up are going to be acute angles. So generally, a complementary angle will look something like this. So angle AOC and angle COB is a complementary pair. Why? Because they together make 90 degrees. So angle AOC plus angle COB is equal to 90 degrees. Then they are called a complementary pair or complementary angles. There can be more than two angles in this, but for sake of simplicity, we just consider two angles. Okay. Next one is called supplementary angles, and these are very widely used in our parallel line concept, and in when we go to quadrilaterals and when we do plane geometry. Supplementary angles are a very widely used type of angles, so you need to really understand supplementary angles. So what supplementary angle means is their addition is 180 degrees. Now there are two types of supplementary angles again. One is where they are in a pair like this. Okay, not like this, sorry. Like this. And together A O B C. So angle AOB plus angle CBO is 180 degrees. These are supplementary angles. Or there is something called as linear supplementary. We will know more about these kind of supplementary angles when we start doing the parallel lines. But we'll first talk about linear supplementary. So linear supplementary means that all the angles, they lie on one single line and they originate at one single origin. Okay. So it's A, B, C, D, E, and O. So basically, linear supplementary means that all these angles, okay, so I'm going to list them down. Angle AOB plus angle BOC plus angle COD plus angle DOE. Together they make 180 degrees, and all of them have their vertices on one single point, on a single line. So basically AOE angle is a straight line. Okay, so then only they are called as linear supplementary. Now, whenever you have questions of this kind, you can just write the reason as linear supplementary. Okay, one fun fact or one very important fact. Whenever we are doing anything in geometry, each and every step you do has to be supported with a mathematical reason or a geometrical reason. So, writing linear supplementary when finding out the angles were within 180 degrees is a very correct reason to give. So when we go into those kind of questions, you'll understand what I'm saying when you have to write reasons, because geometry, everything is related to some kind of facts or some kind of theorem or some kind of rule that you have to state when you are writing your answers. Okay. Now, next one is called angles around a point. This is also one of the um, type of angles that come up very frequently, angles around a point. And all these angles add up to 360 degrees. So they are giving a complete circle. So let's see. This is my first arm. This is my second arm, this is my third arm, this is my fourth arm, this is my fifth arm. Okay. There can be many more angles here, not necessarily only these many. A, B, C, D, E. Okay, and this is O. So what it states is angle AOB plus angle BOC plus angle COD plus angle DOE plus angle EOA all make up 360 degrees. So if you put here and do this, they all make up a circle, and the measurement of the entire circle is 360 degrees. So angles around a point is also something that is very important when it comes to geometrical deductions. This is the initial step of something called as deductive geometry. Okay. Now the last type of angles is vertically opposite. Okay. And these also play a very important role when it comes to deductive geometry or geometrical proofs when we will be doing them afterwards. So what vertically opposite angle means that when two or more lines intersect each other. So let's start with two lines first. So when two lines intersect each other, this is A, B, C, and D. This angle is equal to this angle, and this angle is equal to this angle. So what they mean is angle AOB is equal to angle COD. See, here they are visually like vertically opposite. They are straight and they are opposite to each other, like mirror image of each other. But angle AOD is also equal to angle BOC, even though they don't look vertically opposite, they're still opposite to each other. They are made by two intersecting lines. So whenever angles are made by two intersecting lines, they are to be treated as vertically opposite angles. And writing vertically opposite is a valid way of answering the question. Okay. So these were different type of angles and different way of looking at angles. Next one, we are going to talk about lines. Okay. So mathematically, a line is collection of points, okay, which keeps on going on the both ends. So this is a line, mathematically speaking. So a line doesn't have an end. It keeps on going. It doesn't have a specific measurement. But when we actually draw a line, we are drawing a line segment, okay, which has definite endpoints A and B. So this is a line segment or part of a line. So generally, whenever we say I'm drawing a line, we are drawing this line segment. But theoretically, a line is one with both the ends having arrows on it. This is AB is a line segment. A line is generally named with a small letter in front of it. So we will call it as line L. And next one is a ray, like we saw in the angles. It has one starting point, but it keeps on going. So let's say OA is a ray. Okay, it starts at one point, but it can keep going. So it is solid at one end and an arrow at the other end. Now, all the points on this line or on this line segment or on this arrow or ray are called collinear points. What it means is that they lie on the same line. So there is one fun fact. Any 2 points are always collinear. So let's say I have random points here, okay, like this. So this point and this point is always going to stay on a line. This point and this point is always going to stay on another line. So 2 points are always collinear. So we don't generally say that 2 points are collinear. We start with 3 points. 3 points can be collinear if they are on the same line. So 3 points are said to be collinear if they lie on the same line. Okay. Now then we have something called as intersecting lines. Intersecting lines is when lines cross each other. Okay. There can be infinite line intersecting lines passing through a single point. Okay, there can be infinite number of lines passing through a single point. These are also called intersecting lines. They are intersecting each other. So what intersecting line means, that these two lines will go and come in contact with each other at some point. So even if let's say some lines are looking like parallel or looking like they will never meet each other, they will go ahead somewhere and they will meet at some point. Okay, so intersecting lines will always meet at some point. The other type of lines are parallel lines, and those are very, very important when it comes to geometry. So parallel lines are the lines which will never meet each other. They always have the same distance between them. This distance is always going to remain the same, like your railway tracks or the lines on your book or the lines on this grid over here right now. They're all parallel lines. They are not going to intersect each other at all. So these were the things we had to discuss today. We will do details of these and few questions on these next time. So let's recap quickly what we did today, and after that we will stop. So we learned what is an angle and different types of angles. Our first angle was zero angle, which measures to 0 degrees. Second one we learned was acute angle, which lies between 0 and 90 degrees. Then we have a right angle which measures exactly 90 degrees, and it is always denoted by this small square over there. Okay. Then we have obtuse angle which is between 90 and 180. Then we have a straight angle which is exactly 180 degrees. So it's always a straight line basically, whether they have mentioned it or no, but it's always a straight line. Next one is a reflex angle. Reflex angles are angles which lie between 180 degrees and 360 degrees. After that, we learned how to do measurements using a protractor. You can use a 180-degree protractor, or if you have a 360-degree protractor, then your life is going to be easier. But general geometry cases will always contain a 180-degree protractor, which is called a D. Okay. Next one we learned was our complementary angles. The complementary angles means when two or more angles add up to become to a total of 90 degrees, then they are called complementary angles. After that, we had supplementary angles. So supplementary angles is when when two or more angles add up to 180 degrees. They are called supplementary angles. Then there is a sub type of supplementary angles which is called a linear supplementary angles. In a linear supplementary angles, all angles need to start at the same point and they need to lie on a straight line. So when all these angles add up to 180 degrees, they are called linear supplementary angles. Then we have our angles around a point, which is 360 degrees. All the angles around one single point. So lines originating from one single point on different directions, together they will make angles of 360 degrees. So all these angles will always add up to 360 degrees. These are called angles around a point. Then we have vertically opposite angles when two lines intersect each other. The angles they are making, the opposite angles, they are called vertically opposite angles, and they are equal. Even though they don't look vertically opposite, if they are opposite to each other because of two intersecting lines, They are still called vertically opposite angles. I know they don't look at. Then we learned the difference between line segment, and a ray. So line is collection of points which doesn't stop; it keeps on going in both directions. Line segment is a part of that line which has a definite length. Okay, line doesn't have a definite length, but line segment has a definite length. Then we learned about ray, which has a one origin point, but it keeps on going on the other direction. Then we know that when three or more points are on one single line, they are called collinear points. Then we learned about intersecting lines. That means when the two lines cross each other, they are called intersecting lines. And if there is one single point through which all the intersecting lines are passing through, there can be infinite number of lines passing through that point. And the last one that we learned here, and which we will be elaborating in our next session, is parallel lines. This is the parallelism that we are talking about. So, parallel lines are the lines which will never meet each other. The distance between the two lines is always going to remain the same. Whatever the length of the line, it doesn't matter. The example of parallel lines are your railway tracks, the lines on your book, then the lines on your graph book. So anywhere the distance between the two lines doesn't get smaller is are called the parallel lines. So we will end here today, and I hope you enjoyed this session, because next session is going to be more interesting with details of parallel lines. So I'll see you next Monday. Till then, you can revise this. As usual, I'm still using the Hayes and Harris MYP book. So if you want, you can get that book for yourself. And from in next session, we will start with details of parallel lines. Till then, bye bye.